In this chapter, we will get your local development environment set up to use Spark. Really, the great thing about Spark is that you don't need anything special installed on your local development computer. You're going to write a regular Java project, and the Spark distribution is embedded in a regular jar. Well, I guess you're familiar with Virtual Pair Programmers courses by now, but if this is your first Virtual Pair Programmers course, then really every course we do follows a similar pattern. You will have been supplied with a zip file as part of this course, which you can download from the Virtual Pair Programmers site. And we've put in there a folder called Starting Workspace. Now this is really basic. There's very little inside this workspace. We're going to be doing all of the Spark work by hand from scratch, but there is a little bit of routine work that I've already done for you inside this project. So you need to open that in your development environment. As always, I don't know what development environment you're using, but for the videos, we use Eclipse. If you're using a different development environment, then I'm going to assume that you know how to use that development environment. Now inside that workspace, I've created a folder called Project, which represents the Java project. In Eclipse, File New, Java Project, and the project name needs to match the exact name as on the folder. So that's going to be Project with a capital P, and that will allow the wizard to automatically configure the JRE. Now the first thing to say is it's really important that you're using Java 8 for this course. We're going to be using a lot of Java 8 features, and really for me, as I said in the introduction chapter, if you don't have Java 8, if you're working on Java 7 for example, then really working in Spark would be a horrible experience. Now at the time of recording, we are in 2018 right now, Spark does not support Java 9. So unless you're absolutely certain that things have changed since I recorded this video and you know that Spark now supports Java 9, then you need to make sure that you are running a JDK of 1.8 point something. Let me give you a quick tour of this project. There's really very little to show you. There's a folder in here, or rather a package, called com.virtualpairprogrammers, and there's a class in there called util.java that we're going to be using later on in the course for one of the worked exercises. We really don't need to think about that right now. Now there's also, we'll need to hunt around for this a little bit because the class path isn't set properly yet, but under the src main resources folder, there are a few subfolders in there, and that's a set of resource files that we're going to be using throughout the course on various worked examples. So we can ignore that for now, but the important file in here is the pom.xml. Now when you open that, you might need to click on the pom.xml tab right here. Of course, you don't have to use Maven on a Spark project. You could be using Gradle or really any other Java build tool, but Maven will do the job for us. And really, all there is inside here is a very short dependencies block where we've supplied you with 3 dependencies. We have the Spark core, we have Spark SQL, many people pronounce that Spark SQL, and we won't be using that dependency on this module. That's going to be a future training course. There's lots of lovely stuff in there, but we need to do the core first. And we also have a dependency on the Hadoop HDFS file system, and more information on that later in the course. But you might be surprised to discover that they're the only dependencies that we're going to need in order to use Spark. So let's get started then, and all we're going to do is create a regular Java class, and it's going to be in the com.virtualpairprogrammers package, and I'm going to call my class main. And we're actually going to be doing most of the work on the course in this single class. Of course, it doesn't really matter what you call this class. And before I click on finish, I'll tick the generate public static void main method. Because this Spark program is just going to become a standalone, kind of like a console-based application. It really didn't matter what you called this class, but I should just draw your attention to the fact that inside this util class, I have referred to that class name here on line 28. So if for any reason you've gone for a different class name, then you might need to make a change right there. We don't need that util for quite some time anyway. Before we do any serious work with Spark, I just want to test that your Spark jar files are working correctly. So I'm going to write now a very basic Spark application. In fact, it's a Spark application that isn't really going to do anything, but we will build on it through the next few chapters. I just want to check that everything's working okay. So for any Spark program, we're going to need some input data. Now, as I mentioned in the introduction, this input data is going to be big data. It could be gigabytes, it could be terabytes or exabytes, or it's going to be a lot of bytes. But of course, when we're working locally, we don't want to be dealing with great big unwieldy files that are going to take hours to run. So it's very common when we're developing to create hard-coded, small data sets that we can hold in memory just to check the work that we're doing. And a nice feature of Spark is that we can do that by using a regular Java collection. So as a start point, I'm going to create a simple list of, doesn't really matter, I'm going to go for a list of just numbers. So let's create a list of doubles, and I'll call this input data. And that's going to be a new array list that's initialized as empty. So I'll do my usual Control or Command Shift O to organize the imports, and be careful to select java.util.list. Now I know that you're an experienced Java developer, so I'm really patronizing you here at this stage, but I just want to make sure that everybody's at the same point. Now we are going to be picking up a lot of new style Java syntax on this course, and I suppose the first thing I should mention is that, and I can't remember when they introduced this into Java, but if you have a collection and on both sides of the collection you're using a generic type, you don't need the second reference to the type. If I leave those double angle brackets empty, then Java's going to infer that, well, obviously the type inside here must be the type inside here. So a minor syntactic improvement there. Now what I'm going to do in this input data is just add some data. Now we're going to add some numbers in here. It can be any set of numbers that you like. They've got to be doubles. And I'm bored already, so that's going to do for now. I promise you that the data will be getting bigger later on, but that's enough to start with. Now, I introduced in the opening chapter the concept of an RDD in Spark, and that really in Spark Core is the most important concept in Spark. It's a resilient distributed data set, and it's this RDD that we're going to use to distribute our data across multiple computers in a cluster. And we can very easily convert this input data into a Spark RDD. So we need to create one of these RDDs from our input data. To get Spark started, we do have to do a little bit of boilerplate code first, but it's not too bad. We need to create an object of type spark_conf. And this, as the name suggests, is going to represent the configuration of Spark. So this is going to be an object which I'm going to call conf, and it's an object that we directly instantiate using new. But then, as is the fashion now, we can then go on and we can call various methods. We can call various methods in a chain to specify the configuration that we want. Now already we can see that this spark_conf class is not being recognized, and I'm getting nothing on the IntelliSense. And the reason for that, I'll just add the semicolon for now. The reason for that is, of course, we haven't downloaded any of the jar files. So to do that, we'll need to run the POM. So right click on the POM and run as Maven build. And we're working in Eclipse, so we'll use the Eclipse :Eclipse plugin and run that. And that will run even though the code isn't compiling. Now I'm guessing this is the first time that you've used Spark, so you'll probably see a lot of downloads going on at this point. I've been using Spark for a while now, so I'm not seeing any downloads. I'm just getting wrote Eclipse project, blah, blah, blah. Hopefully you'll see a build success there. And now if you do a refresh on the project, so either F5 or right click and select refresh, the big difference now will be under reference libraries. Well, we only had, I think it was 3 dependencies in the POM, but of course there are a lot of transitive dependencies that have been pulled in. You should be seeing a lot of jar files there, some of them referring to Spark. So that's our build environment, okay. So now, again, Command or Control O should be importing the Spark conf object, which comes from, not surprisingly, org Apache Spark. So as I was saying, we can now go on with this Spark conf object. We can hit the dot and we can call various methods to configure Spark. Now we don't really have to do much to configure Spark. One of the methods in there is the set app name method, which allows us to give this application a name. It's just a string. I'm going to call it starting Spark. You're going to find that this name will appear in reports, and we'll be looking at that later on. One other thing we need to do is call the set master method. Now I'm going to be explaining this in a lot more detail in, I think it's going to be the last chapter of the course where we look at performance. For now you can just copy what I'm doing. In here we have the string local, followed by square brackets and an asterisk. Close the square brackets and then you can close the string. Now what that is saying is that we're using Spark in a local configuration. We don't have a cluster. And the star means, and I'm not going to be completely accurate here, I will be explaining in full detail on the chapter on performance, but this means use all the available cores on your machine to run this program. As I say, full details coming up later, but just very briefly, if you didn't have this in place and I just said local, then what would happen is your Spark program would run on a single thread. And by running on a single thread, we're not going to get the full performance of this machine. So now I haven't been fully accurate there, but that will do for now. An asterisk in square brackets you're going to see is a very common pattern for the opening line of a Spark program. A bit later on in the course we will be changing what we see in there. But we've a long way to go before we get there yet. We've set up the configuration and now the next line of code is going to be, I need an object of type Java Spark context. Now this Java Spark context represents a connection to our Spark cluster. We don't have a Spark cluster just yet, but this object is going to allow us to communicate with Spark. It's common to call this object SC. And again, we can directly instantiate this object. This is going to be a new Java Spark context. The constructor will take a parameter, which is the conf object that we created on the line above. Another Command or Control Shift O should give us an import. So that's great. Now we're basically up and running with Spark. We can now start doing operations against Spark. And the first thing you will need to do is load some kind of data into Spark. Again, I know I've already said it, but this stage will be where we're going to suck in a file from a big file system such as Amazon S3 or a HDFS system. But for now, we're going to use this local input data. And to load a Java list into an RDD, we use the method which perhaps isn't very intuitive. It's called parallelize, which sounds a bit scary, but really it means load in a collection and turn it into an RDD. As you can see here, it's demanding a single parameter, which is the list that we're working with. So for us, that's the input data, and that's going to return us our RDD. Now, because Java has a very different syntax to Scala, and as I mentioned in the introduction, Spark is implemented in Scala, and actually a lot of the objects that we're going to be dealing with on this course are written in Scala. Now we won't feel that, generally at least, we won't feel that in the Java, but it's worthwhile knowing that that's what's going on. Now because Scala has a very different syntax to Java, the creators of Spark have provided various classes to sort of bridge the gap between our Java and the Scala. And the first one of those that we're going to meet is the object called the Java RDD. I'm going to call this object my RDD. The Java RDD is a Java representation of one of these RDDs. It's going to allow us to communicate with this RDD using regular Java methods and Java syntax, but actually under the hood, this Java RDD is communicating with a Scala RDD. So you can think of this class as being a wrapper. If you're really interested, and you might be looking at the source code of these classes at some point in the future, it's worth mentioning that the Java RDD is actually implemented in Scala itself, which you don't really need to know, but the important thing is this Java RDD allows us to communicate with this RDD as if it's a regular Java object and we're going to call regular Java methods. Now we have a couple of compile errors here, so the first one will be that we haven't yet imported the Java RDD class, so a command or Control-Shift-O, and can you see there that it's coming from the spark.api.java package. Okay, well that's compiling, but I don't know how well it's coming across on the video, but I have some yellow lines underneath there, and that's because I'm being given a warning. Well, the warning's not appearing in the problems, but if I hover, you'll see that this warning is related to generics and the fact that Java RDD I'm currently keeping as a raw type. Now that warning is really just saying if we carry on like this, then we're going to have all kinds of problems downstream working with this RDD, because we're going to have to constantly, every time we call a method on the RDD, we're going to have to remind Java what the type of data we put into this RDD was. So the Java RDD is a generic class, and we're able to specify in the double angle brackets what type of data this RDD is working with, and we know that for us we're working with doubles. So we'll put double in angle brackets, and that's good. We've now got two warnings. This warning's fine. This is just saying, the one on my RDD is just saying, well, you've never used this variable. That's okay, we'll be fixing that shortly. And one annoying warning here is this Spark context. Now, in theory, we're supposed to close this Spark context when our program is finished. So the very last line of code should probably be sc.close. As you're probably well aware in Java, the usual recommendation is, in case of an unchecked exception being thrown in the middle of here, really this sc.close should be in a finally block. In all my experience of working with Spark, they don't bother going to those links because generally we're not going to see an unchecked exception in the middle of this code anyway, because we're going to make it work. And if there is an unchecked exception anyway, then the whole job has failed and we're going to abandon the whole process. So I don't think you really need that sc.close, but I'm going to put it in anyway. Enough talk. We haven't done anything with this data yet, but we have turned it into an RDD. It would be interesting to see if this code will run. So we'll run this as a regular Java application. And well, okay, we have a lot of red text here, but it's just logging, and I hope you can see that most of it is just info logging. There is one warn line here. You might not see this. This is just complaining that it can't find the native Hadoop library. Now, that's really not a problem because we don't need the native Hadoop library for the work we're doing. Now, this logging is quite annoying, really. None of it's useful. And we'll get in the way of readability later. So I suggest before you set up the Spark conf object, what I would normally do on a Spark project is I would configure the logging. Now, of course, you can do this using a log4j.properties file, as you might have done in the past, but actually far quicker on a Spark program is just to get hold of the logger object Now if you're going to do this, be very careful that you get hold of the correct logger object. It is not the Java util logging, and in fact I've got at least a dozen different logger objects or interfaces on my class path. The one you're looking for is the log4j org.apache implementation of logger. So make sure very carefully that your import for logger matches the one I have here. And on that logger object we can call getLogger, and if we pass in actually org.apache, that's going to filter out all of the Apache libraries logging. And we could call the setLevel method on that, and I suggest that maybe what we should do is set level.warn. And again, make sure you choose the right one here. You need the log4j version, and check the import there. Now that's going to filter down the logging so we can only see warnings. If we run again, the program runs through with just that boring warning that we can safely ignore. But we have at least got started. We've got rid of the boilerplate code here, which initializes the Spark context. We've got our first Java RDD set up. Well, we're going to want to do some operations on this RDD. So in the next chapter, I'll show you a very common operation to perform on an RDD, and that's called a reduce. So I'll see you in the next video.